Okay, so today we are going to talk about the weighted average. We have learned about the average, but we have not talked about the weighted average. So in average, what we learned, let's say we have some data points in a series or any list or in a classroom or whatever you want to use, any kind of series in list. So let's say this is the value 2, 10, 5, 7, okay? And if you have to find the average, let's call it some set S. And if you have to find the average of this set S, then what you do, you take the sum of all the elements 5, 7 plus 8, and how many elements are there? Sum of the values of those elements and the total number of elements. So basically 1, 2, 3, 4, 5. So this is your sum of values of elements. Elements means these members. Okay, these are the elements. And then number of elements. Number of elements. Okay. So this is the simple formula to compute the average for a given series, given list, given set, okay, anything. But what if all these elements, they have some value, some weight assigned to it? Let's say this has 2, this has 3, this has 1, this has 2, and this has 4. So in that case, the concept of weighted average comes into the picture. I am giving an example. This is not a good example to understand the concept of weighted average. Okay, take this example. You go to the market, okay, to buy fruits, and you have apple, then orange, 3 fruits, let's say orange, and banana, and let's say here price per kg, or if you want to use American unit, you can say per lb, per pound, okay? And then here quantity in, since I'm using the American unit, pound, I will use quantity also in pound. If you want to use metric units, the rest of the world that uses that, so kg, so you can use kg there, whatever, it doesn't matter. This is not the thing of concern. Thing of concern is what is weighted average, okay? So apple price in lb is, let's say, $3 per lb, and you purchase 4 lb, okay? And orange is let's say $4 per lb, and you purchase 3 lb, okay? And banana is $2 per pound per lb, and you purchase 5 lb, okay? Now if I ask you, what is the average price for the fruit you purchased, okay? So for such scenario, the concept of weighted average comes into the picture. Now you understand what is the weighted average? Well, this was not a good example, so that's why I thought, okay, some real world example, because you go to the market, you buy different types of fruits, and all these fruits have different price, and you buy different quantity of those fruits. So if someone asks you what is the average price you paid for the fruits, then you will use the concept of weighted average. So we'll solve this problem. First, let me write weighted average. This will be like, you can say, value of the element times its weight, okay, and you remember this symbol sum, okay. So it means you have to multiply the value of an element by its weight, take the sum of that and divide by the weight of each element. Okay. Element is nothing here. Element is apple, orange, banana. Okay. In this real world example, your elements are apple, orange, and banana. And in this set, elements are 2, 10, 5, 7, 8, and their weights are 2, 3, 1, 2, 4. Okay. So this is your formula, weighted average. So now solve this example. I will call it WA. Okay. I'm confused by the act in Washington. So WA for this fruit example. So what I will do, I have to compute the value of numerator, value of an element. So what is the value? Its value is $3 per pound. Okay, look at the board first. So this is the value, this is the quantity, its weight. So I will multiply these two. So 3 times 4, correct? Plus, what is the value for orange? $4 per pound, and 3 pound is the weight. So 4 times 3 plus, for this one, 2 times 5. And divide by the sum of the weight. So 4 plus 3, 7 plus 5. So let me write it down first, then we'll now solve this one. 4 times 3, 12. Again 12 plus 10 divided by 12. Okay. So this is 24 plus 10, 34 divided by 12. And if you solve it, so that will be 34 divided by 12. Okay, continue. So you can say around $2.83 per pound is the weighted average. So the average price for the fruit you paid is 2.83. You got it? So you understood the concept, and understood the concept like what is the weighted average. Now solve this example. Weighted average of S will be what? So element value is what? These are the elements of this set. 2, and its weight is 2. 2 times 2 plus 10 times 3. This is value, this is weight for each of them. Okay. 10 times 3 plus 5 times 1 plus 7 times 2 plus 8 times 4. Divide by the sum of weight of each element. So that is 2 plus 3 plus 1 plus 2 plus 4. Okay. So this is 4 plus 30 plus 5 plus 14 plus 32 divided by 12. Okay. This is 34, 39 plus 14 plus 32 divided by 12. It is correct. 39. Okay. Look at the board. There's no mistake in the sum and anything, multiplication. Everything looks correct to you. So this one will be 84 and 10 0, something like around, you can say 7.1. Okay, there is some 7.0, some value, but weighted average is 7.1. Got it? So now it should be clear. It's not difficult. In the normal average computation, what you did, you took the sum of the value of all the elements divided by the number of elements. Okay? In the weighted average, what you are doing, you have two things. One is the value of element and its weight. So you multiply the value of an element by its weight and then take the sum for all the elements. Like for each element, you will do the same thing. Value times weight, value times weight, value times weight, and then take the sum of those quantity and then divide it by the weight, sum of weight of all the elements. Okay? That will give you the weighted average. Now, let's talk about another real world example. So let's say in a semester there are 3 exams, okay? Extra. So there are 3 exams. Exam 1, exam 2, and exam 3. Okay? And someone scored, let's score each, 90, 80, and 75. Okay? So if I ask you what is the average test score, what you will do? You will do, okay, 90 plus 80 plus 25 divided by 3, which is 170 plus 75 divided by 3, which is 5. 245 divided by 3, which is 81 point something. Okay? Look at the board. So if I ask you what is the average test score for that particular student in that semester, you will just take the sum of these 3 scores and divide by 3. This is average. But what if the teacher said, okay, the first exam carries just the weight of each of these exams are different. So basically, if you score more in this exam 1, it will not affect your test score. Let's say it has weight 2. But if you score more here, it will affect your score. Let's say this one has a weight of 5. And this one also has 10. Or maybe use 10 here and 5 here. Okay? Look at the board. First understand. What is happening? That the student got 3 different marks in the exam. You computed the average using a simple formula. But teacher is saying that, okay, the third exam has the more weight. If you score more marks in the third exam, your score will be more. Okay? If you score more in the first exam, it will not weight higher. Okay? So she assigned some weight to these 3 exams. And now she wanted to compute the weighted average, and that will give the final grade to the student. Okay? So what you have to do, weighted average here. This is another real world example. Are you understanding this one? So now all 3 exams have some weights assigned to each. So first one is 90 times 2, 80 times 5, 75 times 10. Okay? And divided by the weight. 2, 5, 7, 17. Oh, bad number. I selected bad number. Let's take 3 here, I hope. Okay? 3 here. 2, 3, 5, 10, 15. Okay, let me write it might. So what I am doing, multiply these two, multiply these two, multiply these two, and take their sum, divide by the sum of weight. You can write later, okay? So this is 180 plus 240 plus 750 divided by 15. So now take the sum of these. Is it correct? 0, 5, 4, 9, 9, 8, 17, 1, 1, 1, 2, 2, 4, 4, 7, 11. Okay. You look at the sum. Now do the division here. 15. All right, we got the correct combination. Okay. Correct. All the sum and division are correct. Okay. See, he got 78 weighted average. Okay. So, although his average was greater than 78, but his weighted average is 78. So this is how we apply the weighted average concept to the real world problem. And these are the things, these are the types of questions you will see in the exam. Now, one thing about the weighted average we are going to discuss. Sometimes some values are missing. One of the example could be related with time distance problem. Take that example. Or the thing we were discussing yesterday. First, let's talk about that. So what happened? Student scored how much? 50%. Some student A scored how much? 50% out of 60% completed task. Okay. Okay, the goal is to score 60% out of full task. Okay, or task completed assignment, not task, assignment. Okay. So how much assignment is remaining? He completed 60%, remaining is 40%. He had scored only 50% out of that 60%. Now, in the remaining, how much he has to score? Let's say X percentage out of 40% of the completed task, so that his average will be 60%. So this is also part of the weighted average problem. Okay. Now here we have some missing information. We have been given the weighted average, which is 60%. Okay, but one information is missing here. We have one information here, another information here, but this is missing, and the final weighted average given. So what we have to do, we have to use you can convert this one into an equation, or without converting into equation, you can also solve. Let's think about this. So completed task is, let's say 100 each completed task. Okay. So he completed 60 and got marks scored. 60%, so 60, and out of that C got 50%. So C had 30. Okay. Now goal is what? 60%. 60% of 100. Full assignment is 100. Okay. Full marks is 100. And goal is to get 60. How much C has yet scored? 30. So how much is remaining? 30. Correct? Because goal is 60. You have to score 60% out of 100. So goal is what? Goal is 60. 60% of 100 is 60. So remaining, how much score C has to get in remaining 40%? 60 minus 30, which is 30. Now C has to score, since we are taking full marks is equal to 100. So 40% of 100 is 40. So percentage, how much percentage C has to score? 30 out of 40. Correct? Do you understand here? So it is 75%. So C has to score 75% in the remaining assignment to get an average of 60%. Did you understand? Let me repeat again. Let's assume that total marks is 100. Okay? Total assignment, not marks. Total assignment is 100. Okay? Out of that, she completed 60%. Means she completed 60 since we are using 100. So out of that 60, she got 50%. It means how much she got? 30. And goal is to get 60% out of 100. So which is 60. So remaining what is? What is remaining? 60 minus 30 is 30. So now the goal is to get 30 out of remaining 40, because 40% of 100 is 40. So that's why 30 divided 40 times 100 is equal to 25. Okay? Did you get it? So this is another types of weighted average problem. Let's talk about another problem. So a train is going from place A to place B. Okay? For 2 hours, the train traveled at a speed of, let's say, 60 miles per hour. Okay? So what should be the speed so that in this remaining distance, okay, for let's say in 2 hours is reached here C, point C. Now from C to B, what should be the speed? We don't know, so X miles per hour. So that average speed will be, let's say, call it 70 miles per hour. Okay? So again, this is an example of weighted average problem. Although it's a part of time and distance problem, but it's also, you can also call it related with the concept of weighted average. So let's see how much distance it covered in 2 hours. If speed is 60, time is 2, this is 120 miles. Okay, I think distance would be there. And then here I have to find this much distance. So how much miles I can take? Let's say 210 miles. That's easy. Yeah. 210, that will be 90. Okay. So let's say this is total is 210 miles from A to B. Okay. And the average speed you want what? Let me write this. A, B is 210 miles. correct? Then average speed you want, average speed desired is 70 miles per hour. So if average speed desired is 70 miles and total distance 210, what is the time? How much time it should take to cover? Good job. 3. Time will be distance divided by speed, which is 3 hours. Out of 3 hours, it already traveled 2 hours. And what is the remaining distance here from C to B? If AB is 210 miles and AC is how much? 60 times 2, 120 miles. Then CB will be what? Can you tell me CB will be? AB minus AC, whole distance minus this distance will be this distance, correct? CB will be 120 plus 90, so 90 miles. This distance is 90 miles and the train already used 2 hours. So how much time is remaining? Time remaining will be 2 hours is gone. So 3 minus 2 is 1 hour. Okay, got it? Time remaining is 1 hour. Distance remaining 90 miles, and distance remaining equal to CB, which is 90 miles. So now can you tell me the speed? X will be, which is our speed, distance is given, time is given, so simple, distance by time, which is 90 miles per hour. See, it's simple to solve these problems like this, and this is also based on the concept of weighted average. Although here we did not use the weighted average thing, but it's also a type of weighted average problem. So weighted average concept can be from different areas: time, distance, work, people, and then fruits and the price, grading, different areas. Okay, but to solve you have to, okay, if something is missing, what is given, you have to find that and apply that to find the missing thing. So first example about the score, and second example related with the time and distance. Okay, it's all clear? Okay, so I'm going to make a quiz. I'll give you some examples, and that will be also based on weighted average and this kind of problem. So this kind of problem you can also use weighted average, or you want to use this approach, whatever you want, it's up to you. There could be multiple ways to solve a problem. So the way you prefer, you can use that for solving those quiz questions. Okay.